All right, in this lesson, we are going to be moving into quadrilaterals, and we're going to be finding quadrilateral properties. Now, remember, quadrilateral means four sides. Okay, so these are going to be polygons with four sides. What do we know? We already know a lot about four-sided polygons, quadrilaterals. We know parallelograms. You've heard of that. You've heard of rhombus. You've heard of square. You've heard of trapezoid. You've heard of rectangle, right? Square. So those are the things we're talking about. In this particular lesson, the next couple lessons, we're going to be focusing on the parallelogram, the rhombus, the rectangle, and the square. All right, and we'll see why we're going to do that. We're actually going to use our transformations that we already know, reflections, rotations, and we're going to use triangles and turn them into quadrilaterals by using transformations. So that's what we're going to do in this little video here. We're just going to do the first page, and then the rest is going to be done in class. So I'm going to kind of help you and show you what you're going to be doing in class. Basically, we're going to practice it here and then come up with some properties, but the rest of the properties, the most important ones, I think on the video we're going to be doing the most obvious ones that you probably already know, and then in class you're going to be coming up with the ones that we are a little bit trickier, a little bit harder to see. All right, so let's start with what it says to do here. On each of the given triangles, perform a rotation of 180 degrees about point X. Shade the quadrilateral formed and give the most specific name for the quadrilateral in the space below. So what you're going to do is, again, what it says, rotate the triangle 180 degrees about point X. So there's 10 of these, right? So, or 9 of them actually. So we're going to do that. Rotate 180. So remember how to rotate 180. Here's this point right here, and since it goes down 2 and over 1, we rotate 180. We're going up 2 and 1 to the right, so you go the opposite direction. See how it made, you don't have to draw this, but see how it made a 180, it made a 180 degree angle. You got to make a 180 degree angle. If you don't make a 180 degree angle, which is a straight line from that point to that point, you didn't do a 180 degree rotation. Okay, so that's how you know it's a 180 degree, what we just did right there. So there's that point, and then of course if you rotate this one over this point, it just goes here, and if you rotate this over this point, it just goes here. So to rotate the triangle and connect them now, we have the 2 red points and the blue point. So I'm just going to connect those. And look what's formed. Okay, a quadrilateral is formed. What type of quadrilateral is it? Well, it looks that opposite sides are equal because this is just the same as this, and this is the same as that. Okay, and do we have right angles? Basically, do we have right angles? Because it would be a rectangle if we have right angles. If there's no right angles, it can't be a rectangle. Clearly, it's not a square. All right. Do we have right angles? No. Are all the sides equal? No. This is longer than this side. This is shorter. Okay, because this goes up 2 over 4. This goes over 2 and down 2. So this length must be different than this length here. So therefore, we just have a plain parallelogram. So in number 1 here, you're going to put parallelogram. All right, so we're going to go a little quicker now. So if we rotate 180, basically 2 to the left, so now we're going to go 2 to the right. There it is. And then, of course, these two, this one goes here, and this one goes here. So we just connect like that, and we formed, again, what did we form this time? Well, this time, it looks like we have right angles. Okay, it looks like we have right angles. And see how this side is up 2 over 2, and this side's over 2 and down 2, 2, 2, 2, 2. So these sides are all equal, so it looks like we created a square. So in number 2, we're going to put square. All right. Number 3, looks like we just have to go 3 units to the other side. Boom, boom, boom. Right there. And then connect. Pretty easy, right? And what got created? Well, we don't have right angles, so it can't be a rectangle or square. It's either a parallelogram or a rhombus. if we have equal sides, it's a rhombus. And it looks like we do. See how it goes over 3 and up 1? This goes over 3 and up 1. Up 1 over 3, over 3, 1. So it's 3, 1, 3, 1, 3, 1, 3, 1, the horizontal and vertical. Therefore, these diagonals must all be the same length. All of them are the same length. Therefore, we have a rhombus. We have a rhombus for number 3. All right, number 4. All right, so boom, boom, 1, 2, 3 and a half. 1, 2, 3 and a half, so right there, and then these are equal, 2 on each side, so they're just going to transform onto each other when we rotate. There it is. Okay, so let's see. We have no right angles, so again, it's either a rhombus or a parallelogram, and because it goes up 3 and a half and over 2, up 3 and a half over 2, down 3 and a half over 2, down 3 and a half over 2. It looks like all 4 of these are the same length. You could measure them. They are, and this is also a rhombus. It's just a more squished rhombus. Okay, and 5 here, make a 180 here, so it goes over 1 and a half, down 2, so over 1 and a half and up 2, and there it is. And again, do you have that 180? Is that a 180 right there? Yes, it is. That's a straight line. So we know that we did it right. And then, of course, this one goes there and that one goes there, so it's the same idea. Boom. Oop. That's not drawn right. So we got boom and boom. All right. Looks like we have right angles again. So it's either a square or a rectangle. Of course, this is not a square. We don't have equal sides, so this is a rectangle. Number 5, rectangle. All right. Number 6, we got to go from over point X, and we're here. So we got to go straight line, up 1 over 1, 2, 3, and 4. So down 1, 1, 2, 3, 4. And that does make a straight line right there. So I know it's 180, and then boom, boom. So we just connect those. All right. So we don't have right angles. It's either a rhombus or a parallelogram. This one, we don't have equal sides. This is shorter. This is shorter than this. So we don't have equal sides, so this must just be a plain old parallelogram. All right, this one here, 1, 2, 3, 1, 1, 1, 2, 3, boom, right there. And of course, this one creates a rectangle. That's pretty easy. And that was, I did the wrong one. I did 8. Sorry. 8's rectangle. Did you catch that? All right, and then 7. Okay, so here, and we're going here. So it's 1 and a half, 1, 2, 3. So 1 and a half, 1, 2, 3. Right there. We're gonna go boom, boom. So that looks like there's not a right angle because this is going straight down. It would have to go this way if it was a right angle. So it's not. It's not a right angle. So it's just a plain old, obviously it's not a rhombus, we don't have equal sides. Clearly this is shorter than this one. So 7 is just a plain old parallelogram as well. Oh, look how I spelled parallelogram here. Oh my goodness. That's like my pet peeve too. My goodness. And number 9. There's X, and then boom, and 1, 2, 3, 4, 1, and then 1, 2, 3, 4, 1. And there we go. And let's see. Certainly have no right angles. It's a rhombus or a parallelogram. It looks like they're the same length. Let's see here. Is this the same length as that? So let's see, this is 1, 2, 3, 4, and this is 1, 2, 3, 4, 1, 2. So I could do Pythagorean theorem here to see. This is a right angle. So this is 4, and this is 2. So let's do 4 squared plus 2 squared equals c squared. 16 plus 4 equals c squared. This is 20. equals c squared and the square root of 20. So this is the square root of 20, and this is a length of 4. Is 20 the square root of 4? I mean, is 4 the square root of 20? No. So this is actually a little longer than this. So this is just a parallelogram. All right, so what things did we notice about the shape that helped us know what it was? Well, we knew parallelograms because we had opposite sides. Opposite sides were parallel. This is something you should already know. And also opposite sides congruent. Opposite sides congruent. All right. We knew rectangles because we had right angles, 4 right angles. And opposite sides congruent. Okay. We knew a rhombus because all 4 sides were congruent. Okay, all 4 sides are congruent, and it is a parallelogram. So opposite sides parallel. You could just say opposite sides congruent. You could say parallel or congruent because it's both, right? And then a square is all sides, all 4 sides congruent, and also all 4 right angles. All right, so the more you go down here, the more stuff you have. Okay, more strict as you go down the list there. And we're going to look at more properties, not just we're going to look at properties that involve the diagonal, stuff like that in class. We got to really know these quadrilaterals inside and out. So I'll see you then.